Okay, so let's take a look at your test, and I like that you're using the tables and that you're setting everything up like it is. But there were things that when I first looked at it, I wasn't really quite sure what was going on. You got this first problem right, okay, and that's because it has nothing to do with molar mass. So if you have 6 moles of the sulfuric acid, and you only need one per recipe, obviously you can do it 6 times, okay? And then you bring that 6 over here. Every time you do the recipe, okay, so we're gonna do it 6 times. Every time the recipe you need two waters, and so you're gonna do 2 6 times or 12. So that's good. But I was taking a look at this, and this will go to the next problem. Is as I looked at these numbers here, and I got kind of worried because they are not right, and I couldn't figure out what was wrong with them. Okay, so uh, so what we want to do is you want to figure out these are this is called the molar mass, which is in units of grams per mole, and I couldn't figure out how you got to 194.3, but luckily, which is very, very good, you showed me how you got it, okay? So in the first case, what you did was you said you have 2 hydrogens, each hydrogen weighing 1, okay? So both those hydrogens weigh 2, okay, all together. And then you said SO4, you said sulfur's 32, oxygen 16, and you said times 4. And I go, oh, that's what's going on. Okay, and I'm going to discuss this more. But what this means, this chemical formula means there's 1S and 4 O's. Okay, so it's going to be 32 plus 4 times 16, and I'll show that in the next video. Okay, and then I went down here and I saw how'd you come up with this 63? Okay, and that kind of confounded me as well. And what you did with this one is you included the coefficient and figured out the molar mass, and you can't do that. So, and I'll go over that in a couple slides. So, all it is going to be 23. Remember, we're rounding the nearest whole number. Plus 16 plus 1, so this should be 40. You got water. I like water. How did you get 36? Okay. Well, I guess what you did, and I'll talk about. Well, I know what you did. Okay, is that you incorporated the coefficient into the molar mass, and you can't do that. And I'll go over that a little bit. Then finally, sodium sulfate. You did 2 sodiums, which is 23, but you did the same thing here as you did over here. Okay, and hopefully you can tell. Hopefully, as I'm talking about right now, you can see where I'm going to, but I'll explain more in detail what to look out for. I mean, just having a little problem with these coefficients and subscripts and where they go and so. So here's the next problem. So this one uses the actual values. So so we start out 90 grams of water and use 36, okay, which isn't the right molar mass. It's 18, but you use the 2 to figure it out, okay, and you came up with 2.5, which is right. And then every recipe you need 2, so so if you have 2.5 moles and there's 2 moles per recipe, you can only get 1.5. You can do it 1.5 times, 1.25 times. And so you figure that out, and then you brought it over here and over here, which is absolutely right. And then what you did is you figured out how much you get. But again, what you're doing is you're using the wrong molar masses, okay? I like that you did this, okay? Now, even though you may be just thinking, oh, it's this is something to memorize. Remember when anybody talks about dividing, okay? Like if there's, if I have 400 marbles in front of me and I want to get groups of 10, okay? I'm going to say I'm going to divide the groups, divide them up into groups of 40. And if you listen to the words, I said divide up, divide the groups up into 40. So that's where we come. This is where this why this table works with the way of thinking things. Okay, it's just not meant to be. Oh, when I go up, it's divide. When I go down, it's multiply. Think about whenever you divide, you always say, I'm going to divide up, divide the groups up into whatever. I mean, that's what I think is the beauty of this, using this table. Okay, so the next problem, pentane, you didn't balance it. So hopefully you know how to do this from the last test. But you're gonna put put 5 here, get 5 carbons, and then you put a 6 here to get 12 hydrogens. Remember, the number of elements of the atoms of an element are the coefficient times the subscript. So 1 times 12 is 12. So 6 times 2 has got to be 12 is 2 as well. And then you count up the number of oxygens on the product side. 5 times 2 is 10. Okay, plus 6 times 1. So don't even look at this guy. 6 times 1 is 6. I said divide by 2 and put that here. And there you have your balanced equation. And this is where you got this one not quite right. Okay, so you started out with the right amount. You divided the 2112 into groups of 44. And you came up with 48 groups or moles. Every time you have a recipe, you need 1, so you can do the recipe 48 times. And you went about it all the right ways. Okay, very good. Okay. Okay, now let's see your molar masses. So pentane is C5H12, so there's 5 times 12. So 60 this is 5 times 12 is 60. And then 12 times 1 is 12. Don't worry about decimal points right now. It gets overwhelming. What I'd really like to do is just focus on getting whole numbers, okay? Okay, so carbon dioxide's right, water's right. Now, the thing I wondered, if you would have put a 6 here, okay, would have you multiplied this by 6? And I think you may have, which is wrong. Okay, so all right, so that's that problem, and I'll do more in the talk a little bit more when I go over specifics. In the last problem, again, you didn't have it balanced right, but let's just look what you have here. So you have 500 grams, and what you need to do is figure out which one of these you're going to run out of first. So you have to figure out how many recipes you can make out of pentane, how many recipes you can make out of oxygen. So you divide 500 up into groups of 62. You have 6.9 moles of pentane. Every time you do the recipe, you need 1, so you can do it 6.9 times. Now you do the same thing with the oxygen. You have 320 divided up in groups of 32. You have 32 groups. Okay. Now you have, it's divided over groups of 32. Now you have 10 groups. Every time you do the recipe, you need 1. So you can do the recipe 10 times. Now think about this, all right? So this says you can do the reaction 6.9 times. This one you say you can do 10 times. So you're mixing these two together. It's not random, okay? It's not like you're taking just this guy and doing a reaction and this guy and do a reaction. You're mixing these two together. And what it says is you can do 6.9 recipes of this, and this one you can do 10. So by the time you get to 6.9 with the pentane, okay, this will go down to 0. There will be no more of the pentane, but there will be 3.1 of this left over, okay? So you can only do as much as the least amount of recipes, okay? It's like the thing if you have, the recipe says 2 eggs and 1 sugar, okay? All right. Now, if you had 4 eggs and 1 sugar, okay, you can only do the recipe once because the recipe says you can do 2 eggs and 1 sugar. Well, you'll run out of after you get done with the first recipe, 1 sugar, you don't have enough sugar to use up the rest of the eggs, so you can only make 1 recipe. So, and that's what you didn't quite get right here. Okay, you used the wrong. At least you should have used this. This should have been 6.9. This should have been 6.9. And now what I'm going to do is go over a little bit about discussion. Okay, now when you do a chemical formula, remember, so let's say you have water, H2O. Remember, the subscript 2 means there are 2 hydrogen atoms in this molecule. Technically, we could say H2O1, which means water has 2 hydrogens and 1 oxygen. Now, so this is the problem that you had with the sodium sulfate. So Na2SO4, and you seem to have been problem with the polyatomics. Okay, you just got to think of them as a group. So this means there are 2 NAs, 1 S, and 4 oxygens. All right. Okay, what you did, it doesn't mean there are 4 SOs. If I wanted to show that there was 4 SOs, I would have written down SO4, or which 4 is a coefficient SO. Okay, but we don't see that here. All right, so this thing right here, SO4, is called sulfate, and it has 1 sulfur and 4 oxygens. Right, now all the polyatomics should be looked as a group. So if you see PO4, okay, it means there's 1 P and 4 O's. The whole molecule has a charge of 3 minus, not just the oxygen. Okay, now I kind of like, for students that don't quite get this as a unit, it is to always keep it as unit. So I put circles around it, and so forth. In our class we have not had a chemical reaction where a polyatomic has split up. Okay, now coefficients. So the number that goes in front of the chemical equation to balance the equation. So we put the numbers, like in a previous equation, we have 2Na or whatever, 2NaOH, whatever it was. We got this number by balancing the equation. But once you balance the equation, no longer think of it as 2Na, 2 O's, and 2 H's, okay? What you have to think about it is 2 NAs and 2 OHs, or just 2 NaOHs, okay? So one thing you're doing is you're decomposing the whole formula and trying to break it up into some sort of logical sequence. So when we balance the equation, we put coefficients. But once we do that, we forget about it. We forget about why we use it to balance the equation. What it tells us is that every time we do this chemical equation, we need 2 NaOHs. Okay, so hopefully you see here, the main thing is when you see a coefficient, it applies to everything after it, okay? So if you have 2 H2O, don't think of this as 2 H2s and 2 O's. So we did that when you balance the equation, but now you just think of it as 2 H2Os. All right, and because that's what it is. It says there's 2 waters for every whatever. Okay, so let's, and then uh, the molar masses again. Some of the problems you had. Uh, let's look at water. Water has a molar mass of 18. Okay, and you got that on that last problem. So it has 2 hydrogens, each one weighing 1, and oxygen weighing 16. So 16 plus 1 plus 1 is 18. Okay, and then sulfuric acid. Okay, we'll go over this in a minute. All right. Now these two rows here are really important to understand. Okay, this tells me every time I do the reaction, for every 1 sulfuric acid, I need 2 sodium hydroxides, which will produce 2 waters and 1 sodium sulfate. Okay, now these numbers down here don't have nothing to do with the chemical equation. What they have to do is the relationship between the moles and the grams of the substance. And because we do the chemical equation is always in moles, and everything we measure in grams, okay, we are going to have to be able to relate moles to recipes, but we'll have to relate grams to moles. All right, so, and if you notice here, okay, for instance, NaOH, the molar mass of NaOH, we'll go over it in a second, is 23. Don't even look at the coefficient, all right? So it's 23 plus 16 plus 1, 40. This 2 goes here, all right? So don't put 2 times 18 here because it's already taken care of here. Okay, a lot of things that students do, and you kind of did it as well, is that they'll incorporate the coefficient into the molar mass, grams per mole. So they'll figure out it's 18, okay, and then multiply it by 2 and come up with that. Don't do that. All right, the bottom line is this. The coefficients, which is the row that says moles per recipe, tell us the relative amounts of substance per recipe. All right, and that goes in recipe. The molar mass, which is grams per mole, tells me the relationship between moles and mass, and has absolutely nothing to do with the chemical formula. The chemical equation. It should be chemical equation, not formula, and only do with the chemical formulas. So here's how we came up with each one of the molar masses of the different substances. Okay, so sulfuric acid is H2SO4. That tells me there's 2 hydrogens, 1 sulfur, and 4 oxygens. And so it's 2 times 1, 1 times 32, 4 times 16, which add them all together is 98. Okay. NaOH tells me there's 1A, 1O, and 1H. So 23 plus 16 plus 1 is 40 grams per mole. And then sodium sulfate. There's 2 sodiums. So 2 times 23. Sulfur 1 times 32. And 4 times 16 is 64. Add them all. Yep. And you get 142 grams per mole. Right, hopefully it's getting clearer to you. And okay, so the last problem here. So again, just like I said previously, is you're given 500 grams of the pentane, 320 grams of oxygen. You mix them together, and you want to know how much product you're going to make. So you have to figure out which one of these you're going to run out of first. So you have to figure out how many recipes each one can do. So you take the 500 grams and you divide it up in groups of 72, because that's the molar mass. And you have 6.94 moles, and every time you do the recipe, you need 1. So if you have 6.94, and each time you do it, you need 1, you can do it 6.91 6.94 times. Now, the oxygen, you have 320 grams. Each one weighs 32. So you divide 320 into groups 32, you have 10 moles. Okay, the balanced equation tells you every time you do the recipe you need 8. So you can do it at least once. So how many times can 8 go into 10? 1 1/4. So you can do it 1 1/4 times. Okay, so here you can do the reaction almost 7 times. Here you can do a little bit more than 1. Obviously, you're going to run out of the oxygen way before you're going to run out of the pentane. Okay, so you can only do 1.25 recipes of the oxygen and do 6.94. So you're going to have a lot of the pentane left over. All right, so that's how many recipes you can do, 1.25. So bring this number, limiting number always comes over to the product side. And then every time you do it, you have 5. So you can do 5, 1.25, so you can get 6.25 moles. Each one weighs 44. So you do 44, 6.25 times for 275. And same thing with water. Okay, so hopefully that'll help you out. Let me know if you have any questions. Okay.